This time around, we're going to talk about the general principles involved in cornering. When we drive the corner the right way, we talk about driving the line, finding the optimal path through the corner. The primary focus on driving the line is to improve our acceleration out of the corner. And the secondary focus, as it says, is to maintain as high a corner speed as possible as we go through the corner. The main method that we achieve this by is to maximize the radius of the corner. We want the radius of the corner to be as large as possible rather than as tight as possible. And what that will do is minimize the amount of traction that's needed in order to turn around the corner. And if we need less traction, we can go faster so that we can use that traction to greater effect. So the line is the optimal way around the corner. And the basics of that idea may be familiar to you, but I'll repeat them here, which is that, if we look at a corner, we can draw a maximal radius corner around it where the apex represents the geometrical center for the corner, or on the line to the center. And if we drive around the outside edge of the track, that'll give us a maximum radius. If we drive around the inside edge of the track, that'll give us a minimum radius. And this, of course, shows you immediately how attempting to take the inside line on a competitor puts you in trouble, because your corner is a much tighter radius than their corner is, and you're going to have a trouble making that corner at the same speed as your competitor. Or alternatively, you won't make the corner, you'll wash out into them. In fact, the optimal way around the corner is to maximize the radius. So that's this line drawn here, where we've started at the outside edge of the track. We angle our way into the apex at the geometric center of that corner, and then we unwind the wheel and move towards the outside edge of the track again. And you can see that the radius of this curve is a lot larger than either of the other two. That means that we can carry more speed for the same amount of traction around that corner. A couple other things just to mention, because they're used so often, is the area before your turn into the corner is usually referred as the braking zone. And that's where you're going to be slowing down in some fashion. And then there'll be a point where you turn in to the corner, and that's your corner entry area. Generally speaking, you'll have less throttle in this region. We would call it a trailing throttle in asphalt or pavement racing. Then we've got the apex, which is the point where you're going to try be at the inside edge of the track. And then you drive towards the outside edge of the track for your track out or corner exit. And through this portion of the drive, you should be accelerating and increasing your throttle speed. One more point about the corners in this regard is that to drive through the geometric maximum is not necessarily the best way around the corner, because this theory that we've just given you isn't quite accurate, because cornering forces and acceleration forces are not applied equally through the tires. And so what you're better off doing is having what's known as a late apex, where your center point, or your apex point of the curve, where you get closest to the inside, the clipping point as it's also called, is your point of contact. So your line then is modified. It kind of skips the geometric apex, and it approaches the final apex region, the inside clipping point, later in the curve. Now, the advantage of this is you're able to optimize your acceleration, and you're able to get a somewhat smoother brake to throttle transition. And what this is really doing is sacrificing some entry speed in order to allow you to get on the throttle earlier on your exit, so that you begin to apply the throttle and you can get full throttle much sooner, because the arc of this portion of the curve has a smaller radius than if you had used the geometric apex for drawing this curve. So you're able to unwind the steering wheel sooner. That means you're able to get more throttle on. You have more traction for the acceleration, and it's faster. The other aspect of it is that it's somewhat safer, in that because you've done the late apex, you're far more likely to make the corner exit and not drift off track and be unable to make the turn. So there's a variety of reasons. Being somewhat safer, but also getting better exit speed are the key reasons we use the late apex. And it's the most common way to approach most corners, not the only way.